Here's section 7.2, exercise 12, and this is really 4 exercises in one. They give us a region, and our region is y equal 2x squared, y equals 0, and, well, I should say our region is bounded by these three curves, and so 2x squared, just kind of looks like x squared. Y equals 0, that's the x-axis, and x equals 2 is there. And so it's talking about this region, and that point, if x is 2, is 8. Okay, so that's what we have. And in part A, they ask us to revolve this around the x-axis, so we split it up that way. So our r is just the height of the function, 2x squared. We go from 0 to 2, and so this is the integral from 0 to 2 of pi r squared. So this is 2x squared squared dx. So that's not so bad. Integral from 0 to 2 of pi, and we get 4 x to the 4th dx. And so that is our 4 pi times x to the 5th over 5 from 0 to 2. Well, that's 32 over 5. 32 times 4 is 128. So we get 128 pi over 5. So that's part A with that integral. B, what do they say? So again, we have this picture like that, 0 to 8. And now in B, they say the y-axis. Oh, so we're cutting this up like this. Now this is a little trickier to get r. So for one, we have y equals 2x squared, which means that x is equal to the square root of y over 2. And so that's that distance, but you see that's not our radius that we're adding up. And now you could think of this as that radius and think of this as the washer method. And that's fine. So one way I can think of it is find the solid that's made from rotating this line x equals 2 around this whole thing. Well, that is just a cylinder of radius 2 and height 8. And so one way to get this is, well, first the cylinder is pi r squared, so pi times 2 squared, and then all times 8. And so that's the full cylinder, or 32 pi. Then I could get the volume of this stuff where I add up those radii. Okay, and so, well, and I guess, I don't know, I sort of misspoke there, I think. I said you can think of it this way. Well, yeah, we kind of have to think of it this way. Okay. I think, yeah, well, I don't know. I'll just shut up and keep calculating. Okay. So the outside is our 32 pi, and now the inside is our x value. And so that we're integrating from 0 to 8. We have pi, and our r is the square root of y over 2, but we're squaring it, and then dy. So that is equal to the integral from 0 to 8 of pi times y over 2 dy. So that becomes pi times y squared over 4 from 0 to 8. Well, 8 squared is 64. Divided by 4 is 16, so that's 16 pi. And so our total volume is equal to the 32 pi of the cylinder minus the 16 pi of the inside, and we get 16 pi. Now, we could have said, well, it's pi, we need r squared minus little r squared, like that, and then times h. Well, if we set that up, of course, we'd still be going from 0 to 8. Now, big R squared was just 2, so we would have pi 2 squared minus, and then we would have our y over 2, like that, dy. And so notice, the second part is still just that integral we just did, 0 to 8 of pi times y over 2 dy, and we would get our 16 pi. This first integral, notice it is just the integral of 4 pi from 0 to 8 of dy, but that is just 4 pi times y evaluated from 0 to 8, and that is our 32 pi. So we get it that way even if we think of the washer method with their formula. But again, we can just, don't forget what you already know. We know how to do cylinders. And so that was 32 pi. But we get it here with the integral, and then, of course, minus our 16 pi that we did there. And so we get our 16 pi. Okay, that's A and B. C. They want us to revolve around the line x equals 3. So again, I want my picture. So there's 2. Now here is the line x equals 3. And so we're going to slice this way and send this around. And again, we have a washer type of thing where the outside radius is this and the inside radius is that. Well, here, so the inside radius is fixed. It's 1. So, again, much like B, here I can do one part of it. I've got pi times 1 squared, and of course that was 8, so times 8. And so the inside of this thing is a volume of 8 pi. Now the outside, okay, so again, see, we're revolving around the line x equals 3, so we're slicing this way. And so again, I can take my previous work, and previous work said that was, that line there is the square root of y, that line, that curve, is the square root of y over 2. And so I'm going from 3 to the x value here of square root of y over 2. So that distance is, my outside r in this case is 3 minus the square root of y over 2. Okay, because I'm here and I'm going to here, and I'm going to rotate around that way to make a disk. And so I have 8 pi for the inside, but the outside, the big R squared, I need the integral from 0 to 8 of pi times 3 minus the square root of y over 2 squared dy. And so this is equal to integral from 0 to 8. I've got my pi there, and then squaring that, I get 9 minus 3 square root of y, and then plus y over 4. Did I do that up here? Y over 4 or y over 2? Uh-oh. See, that's where, oh yeah, y over, okay. So you see, I wrote it wrong. It's right, it's the square root of, try that again, the square root of y over 2. So sorry about that. That square root goes over that whole thing. That is y over 2. Let me check that again to make sure. Yeah, okay. Yep, okay. Whew. It's a close one. Okay, so that's y over 2 when I square that, and dy. Oh, well, and of course, that changes this as well, right? Because that middle term is, if I have a minus b, that middle term is 2ab, well, minus 2ab. So here, I need this to be 6, and put that y over the square root of 2 there. So yeah, sorry about that, rewriting that wrong. Won't be the last time. And so, I have this 6, so I'm going to rewrite this just to show it a little better. Got 9 minus, now I've got the constant 6 over the square root of 2. I can reduce that a little bit, times y to the 1/2, and then plus y over 2 dy. So yeah, I could write this 6. All right, 6 is 2 times 3 over the square root of 2, so I could just write this as 3 times the square root of 2, and I'll do that in a moment. So this is equal to, we have pi. Now I do the antiderivative, I get 9y minus, now here's where I'll do the 3 times the square root of 2, and then I have y to the 3/2 divided by 3/2, or times 2/3, plus y squared over 4, and this goes from 0 to 8. So this is pi, and we have 72 minus, now the 3 over the 3 cancel, and so I just have 2 times the square root of 2. 8 to the 3/2. Well, so 8 to the 3/2, that's, let's find a place to kind of write this. So 8 to the 3/2 is the square root of 8 cubed. So that is the square root of 8 squared times 8, and so that's 8 times the square root of 8, which is 8 times, well, 8's 4 times 2, so that's 8 times 2 times the square root of 2. So after all that, here we have 16 times the square root of 2, and then plus, and we have our 8 squared, so 64 over 4 is 16. So a lot of calculation here with this, but So what do we have in all this? Well, we have a 72 minus 16, so that's 56. And then minus 16 times 4. Oh, crap. 16 times 4, the reason I'm saying oh crap is that's 64. And so it looks like I have minus 8 pi. Oh, okay, well, hopefully we can go figure out what the heck I did wrong here. You all, listening at home, you could just chime in. So, yeah, this part C may be screwed up, and we may have to tell you to stop watching after part B and go from there. Now, the reason, one could argue that, oh, well, gee, it's negative. I needed to subtract it anyway. No. So let's see if we can. Give me like a minute and a half here to figure this out. Well, actually, let me put it on pause and I'll look, and if I can find anything reasonable, and if not, I'll just put a note. Don't go past part B on this video. All righty. Well, at least everything I did up there, as crazy as it was just fine. Right here, silly me, 72, not minus 16, but plus 16. So that's 88. So 88 minus 64 ends up being, what, 24 pi. So that is the outside. Outside is 24 pi, and the inside is 8 pi, I think. Yep, 8 pi. And so we have 24 pi minus 8 pi, or 16 pi. 16 pi certainly comes up a lot. I'm not sure why. Okay, so finally D. Hopefully we can get through this one unscathed. Yeah, not so great with numbers. Oh. Okay. Well. Okay, note to put on the thing, as you all were wondering, why was I doing x equals 3? Because I was looking at number 11, part C. So we'll keep it. Why not? And then we'll do the line y equals 8. So this is the real part C. Sorry. But it was still fine math. Well, it was fine math up until I didn't know how to add. But so let's do the line y equals 8. And so y equals 8. Well, okay. So here we go. There's two, whoops, drew it wrong. All right, got to go back up here and look at what I'm drawing. Okay, so looks like that. And we are going y equals 8, which is right there. So we're going to send it around this way. Well, that is a washer method again, because we have this outside part going around, but then the inside part, and again, we're interested in this, so we hollow out that inside part. Okay, So since we're rotating around this way, we're going to slice perpendicular to that. And so that's a dx. So I have the integral from 0 to 2. And I know I need pi r squared. Now, the outside, again, outside, r is a constant 8. Okay, and so the outside is pi 8 squared, and then times our height of 2 in that case. And so that's, 2, our height of 2 in that case. And so that's 128 pi for the outside. Now the inside, all right, it's that distance, but that distance is 8 minus our y value. Okay, so that's 8 minus, and our y value, this was 2x squared, like that. And so we square that, dx. So that's the integral we need this time. And again, in something like Desmos, we could just evaluate it really fast. But it never hurts, I think, to see it, even if I'm doing it for you. So this is, as in, I have problems with numbers. So this is the integral from 0 to 2 pi 64 minus, and then we've got 16 times 2 is 32, so minus 32 x squared, and then plus 4x to the 4th dx. So this is pi times 64x minus 32x cubed over 3 plus 4x to the 5th over 5, and that's from 0 to 2. At least the 0 makes everything go away. So pi, so 2, we get a 128, and then a minus 2 in there is 8. 8 times 32 is 256 over 3. And then plus 4 times 32, so that's 128 over 5. And so once again, we get these nasty fraction things to look at. But once again, I think I'll go with just doing 3 over 3 for the 128, because that ends up being 100, and we get, when we subtract those two, we get 128 over 3. So this is pi. 3 times 128 is 384 over 3 minus 256 over 3. But, 256 is just 2 times 128. So really we just had 128 times 1 minus 2/3. Plus 128 over 5. And so again, the mathematics here, the arithmetic works out nicely in that we get the 128 over 3 plus the 128 over 5. And so once again, pull out 128 pi, and then we've done the 1/3 plus 1/5 before. That was 8/15. And unfortunately, nothing cancels. So 8 times 128 is 1024 pi over 15. So that, again, going back to the picture, that was the inside. So we have the outside was 128 pi, and then the inside, so our volume here is then the 1024 pi over 15. What the heck is that? Well, actually, I have sort of some idea. for one, we could pull out the 128 pi. So this is 128 pi times, and we're left with 1 minus and 8/15. So see, that's not so bad. And so this is 128 pi times 7/15. And so whatever the heck 7 times 128 is. So we've got our pi, we've got a 6 and a 9 and an 8, I guess. Does that sound right? No, that doesn't sound right. 6. Yeah, I know it's terrible having to listen to me, but so 7 times, oh yeah, that does sound about right. Okay, so 896 pi over 15. So there's our volume for C. This is getting to be mighty long, isn't it? Okay, and so I will go ahead and do D. That was the line x equals 2. And so once again, okay, we have this picture. Here's x equals 2. So the first CA, when I did x equals 3, that was probably a bit tougher. We want to rotate that way, so we're slicing it up with the y-axis, and hopefully I can set it up just fine this time. Again, that's 8. Again, our outside, oh, sorry, in this case, as we rotate this around, I guess our distance is just this, and so this is, what the heck is that distance? That's 2 minus, and that function again was the square root of everything y over 2. So that's 2 minus the square root of y over 2, like that. And we're going to need to square that. So I'm just going to do it here. And that's 4 minus and 4 square root of y over 2, which again I can take care of one of the 2's there. And then plus y over 2. So that's what we get when we square that. And so we are doing an integral from 0 to 8 of pi r squared. So we end up with this 4 minus 2 square root of 2 times square root of y plus y over 2 dy. And so we can do that integral. I've got pi and then times 4y minus 2 square root of 2, and that was y to the 1/2, so now that's y to the 3/2 over 3/2, and nothing cancels nicely there, plus y squared over 4, and that's from 0 to 8. Yuck. So this is pi times 32 minus, oh boy, so here we have 4 times square root of 2 over 3. Then we have 8 to the 3/2. What the heck was that again? That's 8 times 8, so we get an 8 when we take that square root, and then times another 2 and the square root of 2, so that was 16 times the square root of 2, and then plus 64 over 4, which is 16. We get that this time. I'll remember to add, so this is 48, and then minus Well, this is 2, square root of 2, square root of 2, so that's 2 times 4 is 8. And 8 times 16. Well, that's 64 times 2, so 128 divided by 3. Okay, well, the nice part is again that 48 is just 1/3 of 128. So, if I factor out the, no, it can't be 1/3 of, what am I saying? I don't know what I'm talking about. Okay, but we can take out a 4. So 4 pi, and I see a 12 minus 32. Oh, we could have taken out yet another, we could have taken out 8, I guess, over 3. So I'm going to do that. 8 pi and 6 minus 16. Oh boy, I'm slow, aren't I? Okay. Could take out another 2, so that's 16 pi times 3 minus 8/3. Finally. So that's 9/3 minus 8/3. That's 1/3. So that's just 16 pi over 3. And that is our volume. 16 pi over 3. Okay, so I think I have managed to get through all of those, and it has taken a long time.